Alright, let's hope we don't face any technical difficulties this time. Let's see. Let's check the stream. Got it open right here just in case. Give me a second just to make sure. I think we're okay. Am I lagging? I got a new mic, so it may sound a little different. Okay. All right. I think we're good. For the most part, at least. Okay. All right. To the workbench. New fucking mic. So hard to deal with. All right. All right. We're going to be doing the same thing as before. But, maybe a little bit shorter this time because it's probably pretty boring. 6 keypads. Also, it takes me so much longer to assemble when I'm streaming than when I'm just doing it by myself, which is already crazy because they take so long as it is. But I figured it's interesting, and I think people liked it last time. These are for the recent few orders, or the next in the queue, I should say. Just wanna, I always give down each PCB a visual inspection. Hey, Pink Pebble, thank you for the follow. Actually, let me test something. Ignore this. Just needed to reload. Sorry, Pink Pebble. You didn't get the notification. All right. Cool. Ready to start. Once again, forgot my solder. Give me 1 second. The goods, the juice, the solder juice. All right. Have the same stencils as last time. Did not clean them after the last time I used them, but hopefully they should be okay. I'm gonna give them a little wipe down with the super strong alcohol, the 99.9% alcohol. This solder paste, it gets crusty when it's dried. But if you let the alcohol soak, it kind of gets rid of it. super crusty. And I don't know if you'd be able to see this. Probably not. But inside the little tiny fine pitch holes, if they get clogged up, and can't have that, because if they're clogged up and they're not putting out enough solder, the connection will be all off, and then it'll be a nightmare to deal with after. All right, that should be good enough. Hold on, let me just fix something on the stream. Okay. Also, if my audio is bad or if the music is too loud, I'm trying a different method this time, and also I have a new microphone, so not sure what it really sounds like. I tried my best to get it right, but I'm not sure. Okay. On with the soldering. Got to glob on a good amount. Even though it's only 6 boards, if you do too little, things start to get uneven. It's way more to scoop back in than scoop more back on. Everything aligned? Barely. I think it's almost time for me to make a new solder stencil. I've used this method of stenciling since the first generation of keypads, when I was only doing like a few a week. It's a lot different now. And I think I need something a little bit more hardcore, a little bit sturdier. But they look pretty good. Here, let's see if we can do what we did last time. Not bad. Got my assembly trays to make my life up just a little bit easier. It says my stream is experiencing issues, but it doesn't show me any dropped frames or anything, so let's just hope that everything's all good. I've thought about it, but sending, it's a little tricky creating something for multiple stencils, because the way that it works is you send the PCB file to the place that makes the stencils, and they then use that file to create the stencil for you. So I would have to create like a fake PCB file with multiple PCBs on there, send it to the stencil house, and then maybe it could work, but I'd be worried about the alignment being off. Also, it's hard enough keeping one board aligned, let alone 3. Properly clean this time, because that was our last noodle pad. I don't know if you can see how gross it gets back there, but it gets so gross. Looks good. All right. Oh, this one's crusty. Might even have some old boards or even an old stencil to try to just scrape away any of the junk that's on there. Everywhere. Oh shit. I've literally never seen this happen before. next one. I think there was something sticky back here. And it might have screwed up this last one, but I think it'll be okay. Alright, looks good. Cool. Yeah, that looks way better. That's the other thing about this particular stenciling setup. It's simple and it's easy, but it's super inconsistent. And you'll see in the later steps that just causes more cleanup for me. And right now, that's like my biggest time suck when assembling these is hand cleaning up all of the assembled units. Get that excess solder. Stuff's expensive. I don't want it to go to waste. And then wipe this one down. I probably go through a liter of full strength 99% isopropyl alcohol a month. It's like so important. It's the only thing that will get the gunk and the shit out of the tiny little trace, the tiny little pad holes. All right, good enough. Good enough for now, at least. I'll do a clean later. Oh, fuck. Oh. I gotta do a thorough hand check after this to make sure I don't have any lead. Or not lead, tin, silver, and something else on my hands. Regardless if it's lead or not, it's still probably not great to have it all over you all the time, which I do, but cool. Stenciling done. Do a little wipe down of my work surface. What to do first? Let's do the noodle pads first. Let's see. Gotta do hand inspection. Don't mind my gross hands and fingernails. I've been woodworking in the shop for a large portion of the day. And it just gets everywhere, sawdust and super glue under my nails, and I already spent most of the day picking off super glue that I glued my fingers together. All right. Cool. Good to go. All right. Step one, component one. I always start with the most difficult to get items, but luckily I was able to get my hands on quite a few more of these. But these are the microcontroller, the brains of the operation. Oh, that's not working at all. Okay, you just have to trust me. Okay. These are super important to get straight right away, because if you watch the last stream, I had to pull one of the microcontrollers completely off and start again after I had already finished assembling everything, because it just wasn't quite lined up right. So the pad on the PCB was touching the wrong pad on the microcontroller itself. It gets a little tricky. Maybe I could zoom in. Get some more light on the situation. Push this over to the side. Pretty good. Step one. Put these away for later. I always start from the top down. Mostly. I start with the bigger components, and then I move to the passives, like the capacitors and the resistors. Then I move to the actual keypad area, like the hot swap sockets and the LEDs. So, but next I have two right here. Light is just getting in the way. Got the USB-C connectors. These are easy, actually. You can really just put them in with your fingers. I gotta grab another one. Luckily, I cut off way too many last time. these bad boys on. Cool. Easy. Next, we do the reset buttons. Simple little tactile switches. They pop on easily. They're really nice because they self-align super well after soldering. I don't have to pay too much attention to them. As long as they're in generally the right place, they will end up straight. Alright. Top row components done. Next, the crystals, the oscillators, the thing that make the whole thing tick. This is also a super simple component. As long as it's in generally the right spot, as soon as the solder starts to melt, you can watch them all get suctioned right into place. Let's see if I can get a better camera angle for you guys, because it's a little difficult. Once those are done, we have these, the ZIF connectors. These are one of the harder parts to actually lay out because they're like the microcontroller and they have to be put on straight from the beginning. Otherwise, it will cause nothing but problems. I guarantee at least 2 of the boards that I assemble today will have bridges on this connector, and a bridge, in case you guys don't know, is when solder jumps between 2 pins. And that's bad because you don't want it to short circuit anything and you want it to function properly. Gotta adjust the lighting. There's just a glare on everything. Huh, that works for now. Alright, you might see my head in here for a second. It's just a lot of pushing back and forth with the tweezers until it seems just about right. The problem though is, since there's solder paste on the pads, sometimes you can't see exactly where the pads are. So you just have to make a best guess. And most of the time, the guess is not always the best. All right. That's done with all the, quote, big components. So I think some of the other ones, I think once we get through the passives, everything should get a lot quicker. Also, if anybody has any questions on the process at all, I'm here to answer them if I can. I always start out with the resistors. I keep them in these little boxes to make it easy to pluck them out one by one. Hopefully soon, I will have a fully automated pick and place machine here at the shop, which would make this task a whole lot easier. This I may be able to get a little closer. A neat trick when working with super small components that have a top and a bottom, like these resistors. So you'll never get them out of the container that they're in the right way they're supposed to be. So I learned a trick from somebody who's been in the electronics world for a long time. And all you got to do is, if they're upside down, take your tweezers, you pick them up and you drop them. Just drop them over and over again. And at least one of the times that you drop them, it'll be flipped back over to the correct side. So if you see me picking them up and dropping them over and over again, you know what I'm doing. That was a first try. Oh, fuck. Of course. Drop the tweezers and knock the microcontroller completely out of place. Cool. Looks good. Tweezer tips are already getting a little sticky from all the solder paste and flux. Which makes these tiny components so difficult. because all they want to do is stick to the tips of the tweezers. Cool. Resistors done. Capacitors now. These are a little bit easier. They don't really have a top and bottom orientation, so as long as they're facing the right way, they should be good. Also, these are another one of the components that really get sucked into place nicely. So alignment's not like a big issue with capacitors. Keep moving the tray out of frame instinctually, because normally I have my face right up against the PCB as I'm doing this out of habit. After doing like over 1,000 of these boards, you get into a real hard to break habits. Like I just fucking did it again. All right, last set of capacitors. Cool. Passive's done. That went really, really quick. Way quicker than the last stream. All right. Now... on to the next step. Just... God, no matter where I put this light, it glares onto the keypad. Okay, whatever. It really depends. From day to day, it could be drastically different. I can assemble one board if I'm in a good mood and I got a good night's sleep. I can assemble one board in like 5-10 minutes. But if it's a bad day and I'm not in the mood and I'm not motivated, it takes quite a bit longer. So next is the diodes. This is always kind of a time-consuming process, but I made this little tool that holds the tape, keeps all the diodes in the correct orientation so I don't have to worry about it. Just pull the tape, pop them back. I'm gonna just power through these as fast as I can. I actually forgot sometimes. Oh, fuck. Sometimes I use hooked tweezers to do this, depending on the situation. Sometimes I find it easier to just place everything down. Let's try that. I did just rattle like 5 or 6 of the diodes all over the place, so it's not going to be quite as easy. With these, just like the resistors, except even more important with these, making sure the orientation is correct, because these are what's called polar components. So they need to face the right way from left to right, and which I almost just fucked up right there, and also be right side up. So if you get that wrong, they just don't work, and the keypad will fail when I'm doing the test runs. So making sure everything is straight and correct is so important with these. That's why they take so long. Also, on Friday, I think I'm going to stream again. And instead of doing the production stream like I've done the past 2 times now, I think I'm going to do something a little bit different. And I'm going to hop in the CAD software, and we're going to design a CNC milled case for the Noodlepad. And ideally, if I could figure out a camera setup, we can machine it here also. But I'm not really sure the best way to get the camera around the shop without having wires dragging everywhere with it, which is a death trap in a workshop, especially with a CNC that's spinning 30,000 RPMs. All right, diodes done. diodes are placed. They look good. Let me just double check that I didn't forget any, because last time I forgot, like last stream, I forgot like 4, and I felt very stupid. Nope, looks good. All right, next, LEDs. Try it with these tweezers also. I gotta turn the AC on in here in a second. It is getting so hot. It's 90 degrees here in Brooklyn today. And I'm in like a old pre-war textile factory building that just does not insulate well at all. So in the winter it is fucking freezing, and in the summer it is so warm. But gotta save that electricity bill. Cool. Final LED. On to the last component of everything. Gotta go grab them though. I have my stash of components. Back over here, my reel of hot swap sockets. They come off and tape like that. So I'm just gonna should be enough for these at least. All right. Hey, Shimber, shoot me an email. My email's down in the description. I'm not sure. What order you're in. definitely shoot me an email and I'll get back to you as soon as I'm done with the stream. These go in so nice and easy, but there's so many of them that take so long per board. And I just spray them everywhere. Oh, fuck. The tape almost just scraped every component off this end board. All right, final. Oh, I just realized I forgot a step in the process too, because it's a newer step in the process, but it's okay. I could do it after the fact. Since this is a newer keypad, we were running into issues with some of the sockets popping out because with the stencils, there wasn't quite enough solder on the pads to really support somebody changing their switches all the time. So what I decided to do was lay in some extra solder paste onto those pads to make sure that the sockets stay where they're supposed to be, just as a precautionary measure. But I totally forgot to do that on this, so I'll do it after the fact. Just squeeze a little bit on. But when this stuff is room temperature, it's so hard to squeeze out of the syringe. So we gotta heat it up a little bit first, but not too much. Otherwise, we'll melt the plastic on the syringe itself. But it's getting nice and goopy. You could see it through the side of the syringe. Also need a piece of paper. Ooh. All right. Just squeezing a little bit extra onto each pad. It's actually kind of a little bit easier to do this after rather than before like I've been doing, because it creates a nice little pocket. The sockets create a nice little pocket for the solder to get kind of caught up into. So I don't know if you could see, but in these little pockets right here, I just filled them up with a little bit of extra solder paste to make sure that they're held in place nicely and they have some structural stability behind them. I'm going to do that for every single pad. Might have to heat this up again. It's getting tough to squeeze through. All right, a little bit more heat. You could see it. It's so satisfying watching the solder paste like kind of melt down and start to get really fluid and nice. I would say that this is probably not a recommended method for normal use. Holy shit, that's hot. But it definitely does what it's intended to do. Perfect. Oh, shit. I think I'm going to start using this method from now on. It's way easier to do it like this. Normally I just squeeze it onto the pads. I have to try my hardest to make sure that the solder paste doesn't go everywhere. And this is nice and contained. Just the right, it's like a little cup for the right amount of solder to sit. Cool. Cool, cool, cool. All right, and that's noodle pads all populated, almost ready for soldering. Just gotta... Cool. Put this off to the side. right. On to the udons. The udons are generally pretty much the exact same thing as the noodle pads, just more switches and different placement of components. I didn't want anything to be too different, so when I'm assembling, things aren't so confusing, and I can easily assemble batches of them together since I pretty much sell equal amounts of each of them. Let's start this process over from the beginning. What do I need first? Oh, right. Oh, Jesus. These are like gold to me. I cannot lose any of them. They are impossible to find internationally. So, making sure that I don't lose any of them is truly a top priority. Because without these, no keypads for anybody. When I was initially looking around to restock on these, the date the manufacturer is giving is what was it? It was November 2023. They should be back in stock. That is a long time. Too long to run a business off of. It would be a nightmare. Luckily, I've been able to find sources all over to be able to handle it, and I harvest them, as I like to say, which I'm going to show on another stream. I was going to do it today, but I still had some left, so I figured it wasn't worth it. Oh, I didn't notice, but we got a few more followers that did not show up. I'm not sure why my follower notifications aren't working. Give me a second while I sort this out. Ignore this notification. Thank you, Brack Crayon. I appreciate it. All right. What's next? The USB connectors. Thank you for the compliment on the audio. I got this mic literally today. All right. Back to work. hopefully the followers work out now. USB-C connectors on. Probably the simplest component of the whole build. All right. Those are done for now. Thank you for the follow. Seems the notifications are working again, thankfully. Next, to my little container of components. Reset switches. Cool. Reset switch is done. The crystals. That technique that I was saying earlier where you pick it up and drop it works well with any flat component. Or the flick. All right, where did I put those? The most annoying component of this entire build. The ZIF connectors. They cause nothing but problems. That one went on so smoothly. I'm a little nervous because they should not normally go on that smoothly. I don't know why I'm having so much trouble with this. I think my head was just in that entire shot. Cool. Big components done. On to the passives. I wonder if I could wire my microscope up to the stream. I don't see why I wouldn't be able to do that. And then we could have a little digital view of what I'm placing. It might work really well for the soldering too. Before I bring out the hot plate, I might try to set that up because it might make everything look way, way, way cooler. All right. Got to try to power through this. I know this part of the stream could be a little boring when you could barely see me placing these little components. Do you like the wide shot or the close-up shot better? Like the full bench or the close-up? Okay, close-up it is. I also wish my stream wasn't so delayed for me. Okay. Alright, just the final resistors. I like that idea. I think when I'm placing the components, I'll stick with the close-up, but anything else, I'll adjust to the wider. It's not hard. I just gotta zoom in and out. But I'm also gonna, next time I do this, I'm gonna try to pull out the macro lens, so I might be able to get better shots. Resistors done. onto the capacitors. Almost just smeared everything across this PCB, which would have been awful. Okay, cool. And just flung some capacitors across my workbench, but it's okay. Actually, it's solder paste, so I don't know if you can see. The lighting might be tough, but that gray paste on all the pads is solder paste. I showed that at the beginning of the stream. So you stencil on this paste, and that's actually the solder. It's a mix of solder, little tiny solder balls, it's finer than a grain of sand, and flux. And you paste it on, and then next step you'll see you just heat it up and it flows all the solder nicely, everything nice and even, so you don't need to worry about hand soldering each individual component. This stuff is the solder paste. I forgot I had it laying right here. It's this goopy paste. And then you have something like this, which are stencils. This is for the old Noodlepad, but I have the current one right here. And then those holes match up with the PCB. Pop the PCB in here. Everything is somewhat aligned. And you just stencil on solder paste, kind of silk screen it on, squeegee it across. All right, where was I? Oh, done with the capacitors. On to the diodes. I have all my diodes over here. Can try those hook tweezers again, see if I was any faster with them. Just got to power through these last few components, then we'll move on to the next step. Sorry for the lack of commentary on the progress. I've now done 3 other boards the exact same way, so the people that have been watching for a while would have heard most of it already, but I'll do another stream soon where from the top to bottom I explain it. Oh my god. This is another project I need to work on. This little thing, because it flings all the diodes out everywhere. It's hard to see, but they just spread out and it does not do what it's supposed to anymore. Because they all need to be the perfect orientation, otherwise it all gets screwed up. There's an impossible to see tiny white line on each component. If that line doesn't match up with the arrow on the PCB, the switch won't work. And when I pull it straight out of the tape, everything is all nice and aligned correctly. So all I need to do is grab it and pop it in. Pop it right on top of the solder paste, then it's good to go. But if they fling out everywhere, the orientation's all fucked up, so I do not like these tweezers. I don't know if you could see, but it is very difficult to see the white line on the far side. My tweezers are so sticky. When you work with solder paste, it starts to get all over your tweezers, and then your components will stick to the tweezers, making it impossible to drop them, so they don't stay where they're supposed to be. No keycaps today, actually, so I should probably remove that tag, but soon. an upcoming stream, we're going to be designing some keycaps for CNC machining. Today, working on production of some keypads. Just trying to get through these last few keypads. This is the most tedious part of the whole process. Oh, shit. Yeah, I run the company called the Mad Noodle Prototypes. I make 2 different models of keypads now. This is just one of them. But small 8 key macro pad with an encoder, and this is a 12 key with an encoder. Once I finish putting these components, I'll show you what one looks like. So you have a frame of reference. If I stop now, I'll lose the groove. Here, let's see. So, we got, this is a red version of the Udon. My camera is tracking my eye, so it's trying so hard to focus on me, so I have to cover my face. But this is the Udon, which is what I'm making right now. 12 keys, encoder. Let me try to. Let me see something. All right. And then my other one, this is a bad example. Let's see, I think I have one in the drawer over here. No knob, but this is the Noodlepad. Smaller version. No screen. Actually, I forgot. I have this one, which I made for streaming. Goes through all my scenes, and I custom I custom laser engraved some little plastic bits to go into these relegendable keycaps. I thought it was pretty cool. They don't look very good, but definitely works for my needs. So if I press the bench button, we're back at the bench. So close to being done. It doesn't matter how big the batch is, even if it's only 6 like I'm doing right now. As soon as you start getting to the last few steps, it becomes so difficult to finish. It just drags on and on and on and on. But I could do 30 in a sitting and I still get that same feeling only on the last few steps of the last boards. It depends on where you get the PCBs from. The PCBs I get from a custom PCB house overseas, so it's fairly inexpensive. Everything else and the time it takes, it can add up for sure. But it's worth it, and making just one keypad is a lot more expensive than making 50, 100, 1,000. With electronics in general, the less you make, the more expensive it is, exponentially. If you wanted to make 50, it'd be a lot cheaper. Well, I don't make custom PCBs for people. I have my own set because it takes quite a bit of time to design and develop the keypad, which is where most of your time is going to be spent. You know, if I were to do it, I would have to charge quite a lot to make it worth my particular time. But a lot of the software that you need to make these things is very easily accessible now. And I'm sure, I know, because that's how I learned, there's a ton of resources online to learn how to use them. It depends on the size of your PCB, how many components, how many drill holes, how intricate the milling of it is, because it could be anywhere from, a few dollars to, if you're ordering domestically, $10, $15 per PCB, or it could be down to just a few cents for just the PCB itself. Not with any of the components or anything. Basically, depending on where you're getting it from, who you're getting it from, the the complexity of the circuit will drastically affect the pricing of the manufacturing of the PCBs. So it could really range from a few cents to $15 to $20 PCB. For hobbyists, though, there's a lot of sites online for prototype PCBs. You should check them out. A US-based site is Oshpark, OSHPARK. They do one-off PCBs just to test it out. All right. The final set of components. Oh, I'm not sure about any EU pricing. That's probably a whole nother ball game. I'm not really sure. Gotta grab more hot swap sockets. All right, the home stretch. Oh, shit. Twice I forgot this step now. All right. Gotta pull these back. Gotta get used to this. The solder paste application, the excess solder paste application. Oh shit. It's leaking. Okay. Oh, I just also realized that I said that I was gonna start applying it after I put on the sockets. I can't believe I already forgot. literally just said it 10 minutes ago. Almost got every pad. To make these cool solder paste applicators that work on compressed air and foot pedal, which would be so nice for these sockets. If I continue to do this, I'm gonna try to think of another way to mitigate the issue that we were having. Cool. Easy peasy. Now, finally, to the final step of the populating of the PCBs. God, my bench is a total mess, as usual after assembly. Okay. Now, back to where I was before. Oh shit. Thankfully, I caught these few missing ones. I don't know why, but every time I'm doing this on stream, I always forget a diode. And in this case, 4 of them. All right, sockets. Cool. think I literally cut off the exact right amount of sockets that I needed. Wait, maybe not. Shit. Damn it. Off by 1. I do think... Oh, yeah. Got one extra one sitting right over on the... Done. So now I have the assembled boards ready to go. Time to do a little cleanup before the next step, which always gets a little sketchy. All right. Okay. Gonna put these to the side and grab the hot plate. Okay. This is the hot plate is now preheating. It's got to get up to temperature. It's going to take a little bit. So while we wait, I'm going to go run to the bathroom. All right. back. Just got a few more degrees before it starts, until it's fully heated up. But once we do that, then the soldering can commence. But actually, while we do that, I want to try to set up my microscope. It's a little bit of a janky microscope, but I think if I do it right, it might work. So bear with me while I do it. Let me deal with this. Let's see. All right. I got it connected, but I think it might be broken. I haven't used this microscope in so long. Yeah, I don't even think it works anymore. Okay, shit. I'll have to figure something else out. But, well, actually, wow, maybe I can set up my macro lens on the overhead camera, and then I'll be able to get a good shot of the solder melting. It's not the best macro lens, but it might work. Also doing all of this right above an extremely hot plate seems like just a bad idea. Let's see. Let's see. I don't think it'll look good. Here, I'll show you what I'm looking at. Oh. It's a manual focus lens, so if I don't nail the focus right off the bat, it's going to look like shit. It might be perfect. I'm not sure. Might work. We'll try it and we'll see how it looks. My phone's about to fucking die. All right, we're up to temperature. Let's see how this works. Okay. We'll do one noodle pad first. See if we could see anything. You can't see much better than when I have the wide angle on. Actually, you probably see worse. It looks pretty cool. Man, that went fast. I didn't even keep my eye on it. Do some quick adjustments. Also, once again, missed another diode. I never miss diodes. And for some reason, this is like the 6th one I've missed. Man, this board soldered poorly, but I'll have to fix it. Cool. Next board. Let's try to brighten it up a little bit. You might be able to see this pretty good. I'm going to end up destroying my lenses by keeping it above the smoke like this. But if I put on the fume extractor, it'll be so loud you won't be able to hear anything. See. Oh. No, you could definitely hear it. Alright, this has got to come off. Is it not that bad? Here, let's get it so it's not in the way. I'll try to bring the mic as far away as possible. Okay, last noodle pad finished. On to the udons. Ooh, definitely got to adjust that exposure. It works pretty well. This is just the second to last one. Thank you for the follow. Sorry for the noise. It'll be over in a minute. Final one. Cool. Just about finished. Want to just let that last little bit reflow through. And the soldering's done. I could already tell for some reason. I think it was because the solder stencil wasn't cleaned properly, but the solder job really was not good today. So I think that's going to cause some problems. So during cleanup, it's going to take a little bit more. All right. Got to wait for the hot plate to cool down, but we've got our cleanly soldered boards. Well, sort of cleanly soldered. I think they're going to be not great, but we'll take a look at them in a second. All right. While this is cooling back down, I'm just going to switch back to the other ones. It is really scary doing this above a 200-degree hot plate. Why it won't work. There we go. Let's see. Okay. Cool. All right, now we know the macro lens works. Oh, hey, Mr. Bland. Nice to see you. While this is cooling down. Gotta clean up a little bit. All right. Got to do the 2-finger scoop because this is a very cheap Chinese hot plate. Everything gets hot. The base, everything. So I have to do the... Oh shit, my camera. The camera died. Gotta change the battery. Just fixing it. Of course. In terms of technical difficulties, this stream is going a lot better than the last one, so I expected this to happen at some point. Don't know what happened. Give me 1 second. Okay, you guys can see me now, right? Hopefully. Well, I'm pretty sure you can, so, all right. Okay, that's out of the way. This is working. Cool. All right. Have to keep the workstation clean. The prep before going through and fixing any problems there were with the boards during soldering. And I think because the soldering was so sloppy that we're going to run into a few issues. I could already see some. What I do is I use this little magnifying loop to check all the connections. But what we can do, let's see. So you could already see right in the center of the USB connector, there is a solder bridge, which is when solder connects between two pins. And that is a big problem, especially on the USB connector that has some voltage going through it and data going to your computer. You don't want that, so you want that fixed. I could see on the ZIF connector that there's a bridge right there. The microcontroller, I think, looks fine, but it's hard to check like this. So this board is definitely bad. Well, needs fixing. The whiteboard, also bad. It's hard to see because of the glare, but there's two bridges right there. I think it's because of the sloppy solder stencil job, but it'll all get cleaned up. Same exact thing with the purple. You can see the big glob of solder right there. It should look like individual pins. Literally every single board has the same issues. So some things, when I was saying in the beginning of the stream, I got to make a new solder stencil. I think the time has come. Oh, this is the only one without a problem. I have to look closer. But I think it looks good. All right. Now, bust out the jig, my little jig that I use to easily hold the boards and for soldering the OLED screens, which slot right into that hole, and the encoder holds everything in place and in line. But what I'll use this for is holding it in place while I clean up the solder. It's going to be hard to see regardless of what I do, so I'm just going to start going. But this is, of course, I got solder paste all over my hand, but this soldering iron tip is way too fat to handle the fine cleanup job that I'm doing, so I'm gonna swap that out. So you can see this slightly angled. Bust out the magnifying glass again. Nope, that's even worse. But it's a much finer tip with a nice angle on it, so I could easily scoop and flick away some of the excess solder paste. Makes it a little bit nicer. I've had the same soldering iron for multiple years. I can't see the screen anymore, but it's okay because I use the same settings every time. And this has, from the beginning of the Mad Noodle, soldered almost all of my boards, or cleaned up almost all of my boards. So what I do, so let's see if we can get an angle. Well, this blocks my vision, so that's no good. What I have to do is we take this stuff. It's called flux, or tacky flux specifically. I use the tacky stuff because it stays where I put it rather than flowing everywhere. I just run a line across the problemed areas. And I'll just run my soldering iron across it. You might see my head in the shot, but perfect. I don't know if you can hear it, but next door I have people singing as loud as they can. But it's a gym, so as long as they're not banging weights, which they almost always are, I'm okay with singing. So this method isn't working, so we have this stuff, which is called solder wick. It's a little copper braid that's embedded with flux, so you can use it to wick away an excess amount of solder. Cool. And just because it gets a little gross and yellow from the burnt up flux, take a little Q-tip of 99% alcohol, clean up the extra, and this should be good to go. First totally complete board. This one's really bad. That worked well. This connector is totally fucked, but I might have to pull it off and put it back on. Yeah, this is totally misaligned, so that's got to be saved for later. It's hard to see. Does that work? Yeah. The pins on the connector are misaligned, so it's just not really working. So I'll have to pull off that connector and start fresh, but I'll do that after I finish the rest of the boards. Okay. That one was nice and easy. A little bit of cleanup. Gotta double check though. Yeah. Looks like this should be okay. Now onto the noodle pads. Same sort of jig. Laser cut acrylic. Thankfully, another easy one. Perfect. Oh, this one might be a problem. I don't know, you could probably see it from here, but this connector is slightly crooked. Also, actually, this one, not as bad as I thought it was. Needs a lot of cleanup though, from all this flux that I squeezed everywhere. It's actually use. All right. Looks good. The final one. Done. Actually, I might as well try to replace that connector while I'm here. Okay. Gotta try to stay neat and tidy. It's already a freaking mess in here. Okay. That hot air gun that I was using before for heating up the solder paste, I'll now use to heat up and melt the solder paste that's holding this connector into place, and either gently nudge it into place, ow, or pull it off entirely, ow. This hot air gun gets very hot. It's not your run-of-the-mill hot air gun. Oh, okay. So it just popped right off. And then ow. I think I got it into place without even need to replace the connector. Looks really good. I need to do some cleanup though, but it should work. Should work well for now. I'm just gonna run some flux over the top of it. Shit, I didn't fix anything else on this board. Just gonna run through, fix these. A little cleanup. Get rid of all that flux jizz all over the board. And we're done with assembly. But now I still need to flash. And I've already been streaming for like, I think coming up on 3 hours, yeah. So I don't think I'm going to do the flashing tonight, but I will next stream, probably on Friday. Maybe I'll show the end of the flashing process, but on Friday I'm going to try to do the Fusion 360 stream where we make a new case for the keypad. Love you too, Joey. All right. I think that's where I'm gonna end it for tonight. See ya.